A body can move along many different paths and still finish exactly where it began. This return to the initial position appears again and again in physics problems. A person can walk from home to a store and return home. A runner can complete one lap and return to the starting line. A clock hand can make one full revolution. Earth can orbit the sun and, after about 1 year, return to nearly the same position. A stone can be thrown straight upward and fall back into the same hand. In every example, the body really moves. The distance traveled is not zero. But displacement asks only two questions: where did the body start, and where did it finish? If the initial and final positions are the same, the displacement is zero. This is one of the most important tests of understanding. A large distance traveled does not imply a large displacement. A body can cover an enormous distance and still have zero displacement. Consider Earth orbiting the Sun. During 1 year, Earth travels an enormous distance along its orbit. After about 1 year, it returns to nearly the same position relative to the Sun. Its displacement over that year is therefore approximately zero. Now consider a stone thrown vertically upward from your hand. The stone rises to a greatest height, then falls and returns to the hand. Let h be the greatest height above the hand. On the way up, the stone travels h. On the way down, it travels another h. The total distance traveled is s equals h plus h, which equals 2h. But the stone's initial and final positions are identical. Its displacement is delta x equals 0. This is a common trap. Because the stone moved a long way, it is tempting to say that its displacement is large. But displacement does not measure how much motion occurred. Distance traveled does. Displacement measures the overall change in position. When the initial and final positions coincide, that overall change is zero. Now compare two stones. Peter releases a stone from a certain height. It moves straight down until it reaches the ground. Mary starts a second stone from the same height. She first throws it upward, and then it falls all the way to the ground. Both stones begin at the same height and finish at the ground. Therefore, they have the same displacement. But Mary's stone travels a greater distance. It first moves upward, and only then travels downward to the ground. Peter's stone moves downward only. Their initial and final positions are the same, so displacement gives the same result. Their paths are different, so distance traveled gives different results. This reveals the deeper distinction. Displacement does not remember the history of the motion. Distance traveled does. The same logic applies when someone returns home, when a runner completes a lap, when Earth completes an orbit, when a clock hand completes a revolution, or when an object rises and returns. Whenever the final position matches the initial position, the displacement is zero, no matter how long or complicated the path was. If this explanation helped, please like the video, subscribe to the channel, and leave your physics question in the comments. We will do our best to answer it.